Okay, gang, let's try 87. So as is, if you do it as is, this is a 3-layered chain rule. The outer layer is the ln, the middle layer is the 1/2, the innermost layer is the fraction. So overall it will be chain rule, derivative of this times derivative of the radical times derivative of the fraction. So it would be 3 layers to the chain rule. So as I've been trying to stress, I highly suggest you use your log properties to make the problem easier for you to solve. All right, so for this one, let me first rewrite it in its fractional equivalent. So the radical can be written in its fractional equivalent. Let me start with that. Now again, let me be clear, I'm not doing the derivative here. I'm just manipulating the log properties. So the first log property I'm going to use is number 3. So that's when you can bring the exponent down as a coefficient, right? So I'm going to bring the 1/2 down. Let me say that a little clearer. It's going to be a multiplier in front. Right? That's a log property. I went over the 3 in the lecture, and I did more. I repeated it again in some of the homework questions. So that's log property number 3. Now, some people might be comfortable taking the derivative here. They might, and that's fine. So if you do the derivative here, you now have gone from 3 layers to 2 layers, the outer layer being the ln and the inner layer being this fraction. And so this would be strictly chain now with just 2 layers instead of 3. So already that is a lot easier to solve. Some people may go an additional step. And remember, if you have division, you can break that to subtraction, and that's log property number 2 that I went over. Just be careful when you do that, that you make sure this 1/2 goes to everybody. So some people may choose to go this additional step of breaking the division into subtraction. You can either leave the 1/2 out front, or you can distribute it in. It's up to you how you want to handle that. So this is as far as it breaks in terms of log properties. So again, you can take the derivative here, you can take the derivative here, or you can take the derivative here. They're all going to give you the same answer. It's just the level of difficulty in terms of solving. So now if I take it here, these are each 2 layers. Anything aside from a ln x is a composite. Okay, so there's an x plus 1, so this is actually a composite. All right, so the derivative of the ln is 1 over the inside. The derivative of the inside is 1. Let me keep the brackets up because I didn't actually distribute the 1/2. All right, derivative of the ln is 1 over the inside. Derivative of the inside of this is a 1. I feel like balancing this already, but I'm going to hold off because I don't want it to be too messy. So let me just write one other layer here. Okay, who did I write wrong? Okay, I caught it. I know some of you are like, she did a typo. If I do a typo, give me a moment because I sometimes catch it and I don't have to do the video over. All right, that's a -1, so I have to make sure I keep this a -1. All right, that was just an accident. That was just a typo. The only thing that I wanted to do is make it a difference. All right, I did my derivatives. Anything times 1 is itself. All right, now I'm going to balance this. So I'm just doing the LCD here. So the LCD is x plus 1, x minus 1. That's all I'm doing here is I'm going to balance this. So I'm going to get x minus 1 to both sides here. X plus 1 to both sides here. Now you got to be careful because you're subtracting this guy, which means that this negative is going to have to go to both of these terms. Okay, so this is a common error right here where somebody only subtracts the first guy and not the second guy. It's like when you go into a movie, they both have to pay admission, not just the front guy. All right, so if I distribute the negative, it looks like this, and then the x and the minus x cancel. This x and this minus x is going to cancel, so you're going to add the ones together. So -1 plus -1, this will add to -2. Okay, so the x and the x went, and the -1's added. Now you can probably see where this is going. You can multiply, or sorry, you can reduce this 2 and this 2. And you'll be left with this. So it's just it's not your job, it's my job to just deal with however you solved it. Okay, so the student that solves it this way, that's fine, as long as they do all the steps correct. This way is fine, or this way is fine, right? You just decide which way that you like the best, you're most comfortable with, and you do it that way. Okay, you don't have to take the derivative in this form. You can convert the form with the log properties. All right, that's my job. To whichever way a student does it, I'll grade that. Okay, you guys just pick the format that you are most comfortable with when you simplify this out. All right, gang, that's it on this one. Catch you. Bye bye.